Oh, hey, Globy. You're probably wondering why I'm wearing all these streamers. Well, I want to find out how aerodynamic I am. Turn on the fan, Charlie. See, aerodynamics is the study of how efficiently air flows around an object, like an airplane or a car or, well, me. All right, Charlie, that's enough. Turn it off. No, turn it off. One of the best ways for scientists to study airflow around objects is in a wind tunnel. A wind tunnel is an enclosed space where the airflow over an object can be carefully controlled and studied. There are 4 types of wind tunnels: subsonic, transonic, supersonic, and hypersonic. The NASA Langley Research Center has all of these types of tunnels and is one of the most extensive wind tunnel facilities in the world. Each type of wind tunnel is used to study an object in a different wind speed.
These wind speeds are based on the speed of sound, which is about 1,235 kilometers per hour, depending on altitude and air temperature. In warmer air, sound travels even faster.
So the speed of sound is how fast sound waves travel through the air. For example, if I were standing in a field and I saw a lightning bolt 1.6 kilometers away, it would take 5 seconds from the time I saw the flash to hear the thunder. The thunder is traveling at the speed of sound, or Mach 1. What? I was just tying my shoe.
Wind tunnels measure airflow, or how fast the air is moving, using the same scale used for the speed of sound.
Subsonic wind tunnels are used to study the airflow around objects that are slower than the speed of sound, like cars and commercial jets. Transonic wind tunnels are used to study aircraft that can fly around the speed of sound. Supersonic and hypersonic tunnels are used to study flight beyond the speed of sound.
In fact, hypersonic wind tunnels can study flight up to 7 times the speed of sound.
But how do the engineers at NASA get a plane to move that fast in an enclosed area? They don't. The object they're testing stays still, and the air moves instead.
We use wind tunnels to provide information on the aerodynamics of various types of vehicles. We can do that in a safe way, very controlled conditions in the wind tunnel. We don't have to build a full-size airplane and risk a pilot's life. We always test new configurations in a wind tunnel first, make sure they're safe, understand their characteristics, and then we move on to building a full-size airplane.
So different types of wind tunnels are used to test different effects wind has on aircrafts flying through the air.
For example, the NASA Langley 14 by 22 foot subsonic tunnel is used to test certain objects that travel at less than Mach 1, or less than the speed of sound.
The 14 by 22 is mainly designed to test low-speed performance of aircrafts. Low-speed testing is important to airplanes in that it's very important to safely take off and land. We consider takeoff and landing the most important part of a flight, because if you don't take off and land safely, the rest of the flight doesn't mean anything. On the other hand, we also test other things besides aircraft in our facility. We test structures to see how wind flows around it, anywhere from large buildings to radar structures. We also test vehicles such as Humvees. And recently we just got into testing motorsports such as NASCARs and Indy racers. And we also tested parachutes as well as a wheelchair in 1979.
The NASA National Transonic Facility uses nitrogen gas to study the flow over wing sections and other models.
Because this wind tunnel is transonic, it's used to test objects that are meant to fly at speeds around Mach 1. Just as sound moves faster in warmer air, warmer temperatures in the wind tunnel make the air move faster.
The Langley 8-foot-high temperature tunnel is a hypersonic tunnel that uses superheated gas to simulate speeds up to Mach 7. That's 7 times the speed of sound. NASA even has a wind tunnel that's built just to study how airflow affects aircraft that are spinning out of control. Whoa, that makes Globy and me dizzy. Hold on, Globy.
You know, Globy, the wind tunnels at NASA Langley Research Center are helping to make air travel even safer and a lot faster. And you won't believe some of the other things that are tested in NASA's wind tunnels. Cars and boats, and even the material for Olympic swimsuits. Leave it to NASA to find a way to test aerodynamics without even stepping outside.